All right. So, Chloe, give part two a read for me.
Counter
Oh, wait. Never mind,
counterclockwise.
never mind, never mind. Read part one for me. What I'm saying. Read part one for me. Part one.
Clockwise rotation of 90 degrees about the origin. Label matrix X.
Yeah, I lose marks today, you know. I not seeing clockwise. I see in counterclockwise. Seeing now they saying counterclockwise.
Oh yes, I know.
Do you know the
Yes, I
difference?
know.
Do you know the difference between counterclockwise and anticlockwise?
No, sir.
All right, so counterclockwise just means anticlockwise. I'll understand that, right? It cannot sound like the opposite of clockwise.
Yes, sir.
What would be anticlockwise? This or this? One or two?
Two.
Second one.
Two. All right. So, Chloe, they want us to write down a 2 by 2 matrix that represents a counterclockwise rotation. Uh, that Chinese food didn't go down good, boy. Give me a second. Oh, I think I vomit. Of 90 degrees about the origin. Label this matrix X. Now, everybody in class, all they going to remember all of this for the yearly exam, all six. I think all they going to have space for all six. Yes,
So
no.
if I cram it,
No.
you might, yeah.
Long story short, most people not gonna have that memory. So let me show you how to do this question. So they want us to come up with a 2 by 2 matrix that represents an anti-clockwise rotation of 90 degrees about the origin. Label this matrix X. Sure, no problem. To do this question, I'm going to draw a unit circle, if that makes sense. Well, not really a unit circle, but I'm going to label the Cartesian plane with units of 1. You'll see what I mean. So I could call this 1 here, call this 1. What would this be? Could somebody tell me what this would be?
-1.
What would this be?
-1.
And what we're going to examine is what happens when you go from, okay, if you rotate 90 degrees anti-clockwise, how is that going to affect the x value and the y value? That's what we're going to observe. So Chloe, you there?
Yes, sir.
All right. So Chloe, I just put on a point where I just placed a point where on the what axis?
X.
On the x axis, right? Now, according to this transformation here, I'm supposed to rotate it 90 degrees in one direction,
Counterclockwise.
counterclockwise, right? So if I were to write this as a point, wouldn't this point be 1, comma 0? This point over here. This is point over here. That's 1, comma 0, yeah?
Yes.
That's 1, comma 0. And I want to rotate this 90 degrees anti-clockwise. So this is what that's going to look like. It's going to look like this. You confused by that? Tell me.
Yes, sir.
Okay, so Chloe, it's a bit abstract, but we are trying to figure out what happens when you rotate a unit vector 90 degrees anti-clockwise. Okay, let me not use words like unit vector. Chloe, what would happen if I take this point here, the most simplest point, 1, comma 0, and I rotate it 90 degrees anti-clockwise? Where would I reach? I would reach 1 on the y-axis. So what would that point be? Tell me, Chloe, what would that point be?
So 110.
Now, remember, when you're writing points, is the x value first, then the y value. So imagine you're over here, right? You're at the origin. How would I move to reach here? I want you to tell me that. How would you move to reach there?
So you went the anti-clockwise direction.
Wait, I'm asking you for the point right now. So if you tell me the point, and to reach there, we just move up by 1 block.
Yes, sir.
Right? Did you move left or right?
No, sir. I just went.
It just went up. So the x value is going to be 0 and the y value is going to be 1. So,
Okay.
Chloe, when we underwent a 90 degrees anti-clockwise rotation, we went from 1, 0 to where?
01.
Exactly. Everybody's seeing that, right? We went from 1, 0 to what?
0, 1.
Cool. Went to 0, 1. Okay. So if you undergo a 90 degrees anti-clockwise rotation, that is what's going to happen to the x value. All right. Okay. Let's consider if you was on the y-axis now. What would happen if you was on the y-axis? So, Christian, let's consider what would happen if you was on the y-axis. Now, I get that this topic is a bit more abstract, but I still think you can figure it out. So, Christian, if you was on the y-axis now, your point would be 0, 1, and if you're on the y-axis, it'd be 0, 1. And we want to undergo a rotation of 90 degrees in one direction.
Anti-clockwise?
Right, anti-clockwise. So that means I would rotate, rotate, rotate 90 degrees. And I would end up eventually at what point?
-1, 0.
Negative 1, 0. Great. So I want you to tell me what happened when I went from, okay, what happened to my x point? So like, what happened to this point? After I underwent the transformation, where did I end up at?
They end up at any negatives,
No, I end up at 0, 1.
or you end up at 0, 1, and then you end up at -1, 0.
Let me check something. Watch that. Nikolai, didn't we prove it? Didn't we just get it just now? You see now, Nikolai? Isn't that it?
Yes, sir.
It's that simple, you know? It's that simple. That simple. So like, let me run through that one more time. So I know that this may be a bit confusing to those that didn't stay back last class, but let me try to understand what's happening. So Christian, we want to rotate something 90 degrees in what direction? In what direction?
Clockwise? I mean, anti-clockwise, yeah.
Anti-clockwise. So for me to figure out this matrix without remembering it, this is what I'm going to do. I'm going to try and figure out what would happen to the x value if I rotated 90 degrees anti-clockwise. And you saw for yourself, if you have 1, 0 and you rotate it 90 degrees anti-clockwise, we're going to end up at,
0, 1.
right? So that's what would happen to the x value. It would now be 0, 1. And now we need to see what would happen to our y value under the rotation. So imagine it was on the y-axis. That would be 0, 1. Now after you rotate 90 degrees anti-clockwise, you're gonna end up where?
At -1, 0.
Right. So that's what would happen to the y value. And that's essentially the matrix. See, in this part over here, you state what's gonna happen to your x value. And in this part over here, you state what's gonna happen to your y value. Are any of you all planning on doing electrical engineering or any discipline of engineering?
Yes, sir.
Yes, sir.
Yes, sir.
So this 1, 0 and this 0, 1, you actually call it basis vectors. All linear transformations are formed based on these basis vectors. Now, you will hear these terms when you start engineering and you start doing engineering maths. But essentially, I'm not sure if I'll ever think about this, right? But Nikolai, if it's 1, 0, and 1, 0 really just represents one space to the right, think about it. Isn't that what 1, 0 represents?
Yes, sir.
So like if I wanted to move 5 spaces to the right, wouldn't that just be 5, 0?
Yes, sir.
So in other words, I could use this 1, 0, which is a unit vector, to go in any direction once it's left or right. I just need to multiply it by something. That's why we call it a basis vector or a unit vector, because we could use that and scale it to go in any direction along the x-axis. Now, why do we call this the basis vector for the y value? Think about it. Jelani,
Yes,
that
sir.
point over there, wouldn't that point represent one unit up?
Yes, sir.
If I wanted to go 5 units up, and wouldn't that just be 0, 5?
Yes, sir.
If I wanted to go 5 down, wouldn't I just say 0 comma minus 5?
Yes, sir.
So you understand that any movement could be represented as a scalar multiple of 0 comma 1.
Yes, sir. So I have a question.
Yeah,
Once you
sure.
multiply this matrix, you'll get back itself. That's why it remaining at one, right? Like to move the factor or no?
You
I was
have it.
thinking
Like,
about something. Huh?
yes, yes. Essentially, yeah, yeah, yeah. So what we are examining here is what happens to the basis vectors under the transformation, because everything else could lead back to the basis vector. The basis vector is like our foundation now. As I would have just showed you guys, this represents a movement on the x-axis. You see this 1 comma 0, and we're trying to see what happened to it after I rotated 90 degrees anti-clockwise. So everybody could see. I know it's all real complicated, and Olido had to know all of this, but I just giving it to students that might do engineering. You go hear about it more in engineering. But for those that just want to understand it quickly, say Chloe, you there? Chloe, you there? All right, so Chloe, we want to figure out the 2 by 2 matrix that represents an anti-clockwise rotation of 90 degrees. Sure, no problem. So to do this, we want to see how the x value is going to be affected, and we want to see how the y value is going to be affected after you rotate 90 degrees anti-clockwise. So Chloe, and you understand at this point is 1 comma 0.
Yes, sir.
So all you do in Chloe is just rotating that 90 degrees anti-clockwise. Where's it gonna take you?
It's 0, 1.
Right, so you put 0, 1 here. That's your first column. And now you need to consider what happens along the y-axis. So on the y-axis, what's our point there? That point is what?
-1, 0.
No, this point over here, this point. Before I
Or
rotate
1,
it.
1.
Now, 0 comma 1.
Oh, yes, sir.
That's the point, right? Now, after I rotated 90 degrees anti-clockwise, what is the point now?
-1, 0.
Right. So that's what happened to the y value. So that is literally all the 2 by 2 matrix represents. So you have a change happening to the x value and a change happening to the y value. That's essentially it. And you don't have to remember anything. You could figure this out in the exam. Now, just to make sure nobody confused, I want to go it over with a couple of you guys. Akira, you there? Akira, let me know if you're there.
So I wanted to ask something. Well, before you erase the graph, it could apply for the 270 degrees, right?
Yeah, this could apply for everything.
All right. Okay.
But as a matter of fact, we'll try it, right? We'll try it and see.
Yeah, I did it already, so I just wanted to ask.
No problem.
Yep.
All right. So Romano, I see you have your camera on. Let me look at this, right, Romano? And the rest of you guys, I know you're probably saying, nah, boy, this is real complicated. Trust, if you give it a chance, you can see really not that bad. All we doing is taking a x value and rotating it 90 degrees anti-clockwise. Wherever you end up at, you put it over here. Then you're doing the same thing for the y value. Wherever you end up at, you're putting it over here. That's all. So Romano, let's
Morning.
let's call this 1 minus 1, 1 minus 1. So Romano, we want to see what happens to the x value after I rotate 90 degrees anti-clockwise. So Romano, where's our point over there? Initially, where's our point?
1, 0.
Yeah, this point over here is 1 comma 0. Great. Now, after you rotate 90 degrees anti-clockwise, wouldn't you end up over here?
Yeah.
Where's our point?
0, 1.
Great. And that's where you're going to put. That hard to understand?
No.
No, that easy to understand. And then we need to see what happens to the y value. Like Romano, if you was on the y-axis, what's gonna happen if you rotate 90 degrees anti-clockwise? Let's see. So imagine you was over here, right? And you rotate 90 degrees anti-clockwise. You're gonna end up from 0, 0, 1 to where?
-1, 0.
That is all. And you put it over here. And you figure it out instantly. Romano, you gonna remember all of that now? You can just do this
Yeah.
you can just do this in the exam. Right? Okay, who might be confused here? All right. Um, Christian, you understand this?
Yes, sir, I understand.
So like you understand we just seeing what happened into the X value, we're putting that down. And then we're just trying to see what happened into the
Yeah.
Y value and I'm putting that down. That's all.
Yes, sir.
Okay, cool. Karina, good night, good night. How are you, Karina?
I said,
You're sounding real tired, boy.
no, sir, I'm not well.
You're
I'm
under
not
the,
good.
you're under the weather.
Very much.
I see. Well, I'll give you a ease up when we're calling you today. But if you're ever confused about anything, let me know, right? Yeah.
All right.
All right, let me call up on somebody random. Regina, you there? Regina, let me know if you're there. Regina.
Yes, sir.
All right, so Regina, be honest with me, right? You think you're gonna remember all of the 6 in the exam?
No, sir.
No. So it will be good to have something to fall back on. So in part C1, they want we to figure out a 2 by 2 matrix that represents an anti-clockwise rotation of 90 degrees. So Regina, a way you could figure this out in the exam is as such. So Regina, imagine you had a point on the x-axis, the most basic point on the x-axis, 1 comma 0. You on the same page with me, right? Imagine you had 1 comma 0.
Yes,
Yeah?
sir.
Okay. After you rotate 90 degrees anti-clockwise, where you gonna end up at?
0, 1, 0,
Right?
1.
You put that over there, that's your first column. So you're showing them what happened to the x-axis. You're showing them what happened to the x value after the 90 degrees rotation, right?
Yes,
Okay,
sir.
now we need to show them what would happen if you was on the y-axis. So if you are on the y-axis, you would rotate 90 degrees anti-clockwise, and you would end up where?
You'd end up with -1, 0.
And you put it over here, because that's what happened to the y value after the rotation. Are you confused at all?
No, sir.
Okay, good. Is there anybody confused? Nia, talk to me, Nia. Let me know if you're confused.
No, I'm good.
You good? Okay, Mira, be honest with me, Mira. Let me know what happening.
Understand, sir.
You sure?
Yeah,
You sure?
positive.
Okay. I take any word for it, eh? I take any word for it. All right. So now that we understand how to come up with it in the exam, let's continue. So part 2. Somebody in class. Okay, Ria, give part 2 a read for me. By the way, Ria, you understand this? Tell me, Ria. Yes or no?
Sorry, sir, I was stuffing my face. Yeah, I understand.
Okay. So read part 2 for me.
Um, Counterclockwise rotation of 90 degrees about the origin, followed by a reflection in the y-axis. Given that Q equals -1001 represents a reflection in the y-axis. Label this matrix T.
Right. So Ria, how much transformations are you seeing in part 2? Tell me, Ria. And the rest of you all in class could also answer. How much transformations are you all seeing in part 2?
2, sir.
No.
Uh,
Wait, Ria, could you tell me 2 transformations you're seeing? Tell me the matrix associated with the transformation. Ria?
uh, um,
Right.
so
So
I
Ria,
don't know.
in part 1, they wanted us to come up with the 2 by 2 matrix for the 90 degrees anti-clockwise rotation, and we're calling that X. That's X. And in part 2 now, they're saying counterclockwise rotation of 90 degrees. What's that? Tell me, Ria, what are you talking about? If you see counterclockwise rotation of 90 degrees, what are you talking about?
Um,
Did you see that anywhere else?
yeah, in the first part.
Right. So this first sentence here deals with what matrix?
The first one?
What we call in our first one? According to part 1, what do we call it? X, right?
X.
So we have matrix X here, and then it's followed by a what? It's followed by a what?
By a reflection in the y-axis.
Right. And they're giving us the matrix for that, right?
Yeah.
That's Q. And they want me to label label the combined transformation T. So I want
Okay.
everybody in class to talk to me. How much transformations are you seeing over there? How much?
Two. Two, sir.
Two, sir.
Gills, Mira, how much transformations you see in there?
2.
All right. Now, if you want to find the combined transformation, you would write it like this. So you'd say T, which is really X followed by Q. Do all of us understand that X is the one that happened first, right? And then Q. Yeah?
Yes, sir.
Okay, now this is the tricky part, right? You might be tempted to multiply X by Q, but when you're multiplying, you're actually multiplying the second one first and the first one second. And no, you cannot switch the order, because if you do that, you're going to get a different answer. Matrix multiplication is not commutative. Basically, what I'm saying is you can't switch the order. If you switch the order, you're going to get a different answer. So if I want to find for T, I'm going to multiply matrix Q. Matrix Q was minus 1, 0, 0, 1 by what? By what matrix, guys?
Matrix X.
What is matrix X?
0, negative 1, 1, 0.
No, 0, 1, negative 1, 0.
That's what she say. She said that. Yeah. All right. So let's do the multiplication now. So matrix multiplication is rows by columns. So we're going to look at the first row. This is the first row. And we're going to look at the first column. So Ria, help me with the multiplication for that.
Negative 1 by 0
Right? Plus?
plus 0 by 1.
Right. No. Jazara. No, I did not forget you. I did not forget you. So Jazara, did you do matrices in school as yet? Yes or no? Talk to me. Okay, and here in Jazara. Ariel, let me know if you're there.
Yes, sir.
All right, so Ariel, we multiplied this row by this column. Are there any other rows to be multiplied by this column?
No.
You're sure? In this matrix, how much rows you have?
Oh, wait, two.
Right.
Yeah.
But what to write?
So would we multiply 0 by 0 and then 1 by 1?
Yep. Okay, so we multiplied all the rows by that first column. So are we gonna stick with that? What are we gonna do now? Are there any other columns in the second matrix? Talk to my guys. So I multiplied everything by the first column. Are there any other columns?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. We have minus 1, 0. So let me proceed now. So Joshua, help me with this. So what am I gonna write, Joshua?
Uh, um, 0.
Nah. So here what Joshua, we multiplied everything here by this column. So now we're moving on to this other column.
Negative 1 by 0.
Nah. So it will be negative 1 by negative 1 plus
Okay. Plus 0. Is it 0?
0 by 0, yeah. So what? Look how it is work, right? So minus 1 by minus 1, right? And then 0 by 0. So the first one by the first one, and the second one by the second one. So redeem yourself, Joshua. So I want you to apply the same concept for the other row. So Joshua, tell me what would I write here?
Is it the same top row and the second one, the second column?
All right, so we already multiplied this row by this column. So now we're going to move on to the other row. So you tell me what to write.
0 by 1.
Nah. So check it out. This is the first one here. This is the first one here. So 0 by -1. I'm now going to do the second by the second. So that's going to be 1 by 0. Okay, Joshua, I'll call you a bit more since I noticed I have some problem with matrix multiplication. I'll call you more. Right? Is there anybody that struggles with matrix multiplication? Let me know, guys. I know it's a sore spot for a lot of students.
Awesome.
All right. Christian, have you ever done matrices in school as yet?
No, sir.
No? All right. Well, let me explain what happened in here, right? Can you see that we have a row here? A row?
Yes, sir.
And this is our what?
This is another that's another row, sir.
Nah. So like, uh, these are rows. These are rows. These are rows. And these are columns. Think about it. When you go to school, you're seated in rows. And columns hold up buildings. Columns are like vertical beams now. So you would say that this is a what? Or what was that?
Row,
That's a row, and this is a
a column.
right. So you're gonna multiply the elements in your row by the elements in the column. So Joshua, pay attention, right? Pay attention to this, Joshua. So we have this row by this column. We're gonna multiply the first element here by the first element here. Hence, I wrote -1 by 0. Then I'm going to add that to 0 by 1, which is the second by the second. So we're done with this. We're done with this row. Tell me, Christian, are there any other rows in this matrix?
Yes, sir.
Yeah, we had a 0, 1. So you see that 0, 1 over there? We're going to distribute that across this column. It's the same procedure. So we have the first here by the first here, plus the second here by the second here. You understand?
Yes, sir.
So you do that for this column, and are there any other columns here?
Yes, sir. There's another column.
Right, so you're going to repeat the same process. So the first here by the first here, plus the second here by the second here. Then 0 by -1 plus 1 by 0. So, okay, do a quick roll call. Ariel, on a scale of 1 to 10, how confused are you, if confused at all?
0.
0, okay. Jelani, you good?
Yes, sir.
Joshua, I noticed I had some problems. Talk to me like on a scale of 1 to 10, where you feel like you're at?
What?
When we were doing the matrix multiplication, I noticed I had some problems with it. So let me know how you're feeling about it.
That's a little confused. That's all.
All right. Don't worry, I'll give you more matrix multiplication to do. Don't worry, I'll remember you. Ria, how is the matrix multiplication on your end?
Good for now, sir.
All right, Chloe, let me know. Did you remember how to do the matrix multiplication?
Yes, sir.
All right, Nikolai Romano, are you good with us?
100%, sir.
All right, Karina. Karina, let me know what's going on.
Yeah, we could say.
Your voice will sound good, but I'm glad we good. All right, Samir, Regina, Mira, Nia, Akira, Jazara, come on, guys. Matrix
Yes,
multiplication.
sir, we got on this. Yes, sir.
Okay, well,
I believe if I didn't know matrices, sir.
after that, after all the marathons, boy, hey, I would be sad. I would be saddened. All right, so -1 by 0 is 0. 0 by 1 is 0, so this is just 0. -1 by -1 is 1. Plus 0 by 0 is 0, so 1 plus 0 is 1. Then 0 by 0 is 0. 1 by 1 is 1, so it's just be 1. 0 by -1 is 0. 1 by 0 is 0. So you're gonna end up with 0, 1, 1, 0. Yeah. Is everybody okay with this?
Yes, sir.
Yes,
Okay.
sir.
No, and I don't understand where now do.
Okay, no problem. Let's go through it in detail. You okay with the matrix multiplication?
Yes, sir.
All right, so all I did was just simplify it. So what's minus 1 by 0? Thelma and Chloe, what's negative 1 by 0?
0,
Right? Where's 0 by 1?
0,
So where's 0 plus 0?
0,
That's why I get is 0. Where's negative 1 by negative 1?
-1,
Nah, a negative and negative is a positive.
1, 1. You win
And where's 0 by 0?
0,
Where's 1 plus 0?
1.
Yeah, that's how I got the values, you know. So watch. 0 by 0 is 0. 1 by 1 is 1.
Oh,
0
okay,
plus
okay.
1 is 1. 0 by negative 1 is 0. 1 by 0 is 0. 0 plus 0 is 0. That's
Okay.
it. So, yeah, guys, you can take a screenshot of this or take some notes. Let's just recap. For part 1, you could come up with it on the spot, or you could try to remember all 6. For part 2 now, anytime you have a combined transformation question, you're going to multiply the second by the first transformation in that specific order to get your answer. All right. So let me get some feedback. I know it's a bit confusing. I feel like this is one of the harder concepts to grasp, but let me know what's going on. I find the silence is alarming.
So all
And
I gotta say is like, I thankful for like what we figure out the night when we stay back.
yeah, because now you don't have to remember anything. Like you could figure it out. You just had to
Yeah,
see.
just a
You,
little sketch. Yeah.
you just had to do a little sketch and see how it's changing on the x-axis and on the y-axis.
Yep.
Right? Uh, Earlier, let me know what's going on. If all you're confused, now is the moment. Now is all the chance. If you understand, let me know what you understand. If you're confused,
So
Yes, sir, I understand, sir.
Yes,
after you could go through the 180 and the 270,
okay, no
the
problem.
other possible. Yep. Thanks.
All right. So I want to do a question for Joshua's sake, right? So I'll take the screenshot. Yes or no?
Yes.
Yeah. Okay. So I'm gonna do a question with Joshua, and the rest of you all could attempt it in the meantime. So we have a matrix A here. 1, 2, 3, 4. Very creative, I know. I'm very creative. Hey Romano. Romano, you see we have a new student here, right? You see Christian, the new student? Christian. Christian, say hello.
Hi.
Yeah. Christian, Romano, you wouldn't believe the number he told us in the Form 4 class. Ask Nikolai.
Oh no. Oh no. Do you even have to tell you already? No. Oh no.
Yeah, boy. Don't know what's wrong with him.
Oh no.
So here what? I want you all to multiply AB. Do the matrix multiplication of AB, and I want you to show that that is not equal to BE. So this is what I want the rest of you all to do. Joshua, we are going to multiply AB. But for the rest of you guys, once you feel confident in matrices, I want you to multiply A by B, and I want you to show that that is not equal to B by A. So, Joshua, let us try to do the question. Right, so Joshua, we're going to multiply A by B. So, Joshua, tell me what matrix A is.
Matrix A.
Yeah, what is
Uh,
matrix A?
well, what's the way how to do it again? The multiplication.
Wait, we're not doing the multiplication just yet. Asking you to tell me back what A was. So, what's matrix A?
1, 2, 3, 4.
Right, that's matrix A. And I'm going to write that right next to -1, 2, 6, 0. Right next to it. Great. So, Joshua, I want you to look at this matrix, right? What is the first row you're seeing? What is the first row?
1, 2.
1, 2, that is the first row. Okay. Okay, that is the first row. What is the first column in the other matrix?
Negative 1, 6.
Negative 1, 6. What is the first element here?
1.
What is the first element here?
Negative 1.
So you're going to multiply 1 by negative
By
1.
negative 1 and then 2 by 6.
Exactly right. You have it there. So that would be equal to, let's do it quickly, right? So it'd be 1 by negative 1 plus
2 by 6.
right. So you multiplied all the elements in this row by this column. Tell me, Joshua, is this the only row in this matrix?
Yes. Well, no.
No. What's the other row?
3, 4.
Right. So we need to multiply.
3 by 2, 4 by 0.
Nah. I mean, technically you could do that and put it over here. But I want to stick to like a specific structure. So, Joshua, we have this by this. So we're going to multiply all the rows by the first column, and then we're going to move on to the second column. So Joshua, what is the first element here?
3. So 3 by negative 1 and 4 by 6.
Yep.
And then the next column would be 1 by 2, 2 by 0, and then 3 by 2, 4 by no,
You have it.
4 by 0.
Yep. See, look how fast you get it. So that wasn't our problem. Yeah. Good job. So those of you guys that did A by B, can you verify that you got this answer? I'm going to do it quickly. 1 by negative 1 is negative 1. Then 2 by 6 is 12. So 12 minus 1 is 11. 1 by 2 is 2. It's going to be 2. 3 by negative 1 is negative 3. Negative 3 plus 24 is 21. 3 by 2 is 6. For those of you guys that multiplied A by B, did any of you all get 11 to 21, 6?
Yes.
Yes, sir.
Excellent job. Now, what if, did anybody get through with B by A as yet?
Still working, sir.
All right.
So is it 5, 8, 6, and 12?
I don't know.
Okay.
I'll be honest. I'm gonna do it
Okay.
quickly. So B is minus 1, 2. Actually, I'll let Christian help me with this one. Christian, I think you see how it is work by now, right? I think you see how it is work. So I want to test you a bit. So minus 1, 2, 6, 0. Christian is like my guinea pig in this class, boy. It's like, because I know like a lot of the stuff you didn't do as yet. So I using you as a benchmark to like see if everybody else understand it. Because I feel like if you didn't do this before and you understand it, I feel like the rest should understand it too. If you understand what I mean.
Yes, sir.
So 1, 2, 3, 4. Because I would have do this with them before. But you seen this for the first time. Right. So I want you to look at matrix B. What is the first row in matrix B?
Negative 1 and 2.
Negative 1 and 2. Great. Great. Negative 1 and 2. Okay. What is the first column in the second matrix?
1 and 3.
Right. What is the first element in the first row?
You have to times negative 1 by 1.
Negative 1 by 1. So the first,
And then
yeah,
plus 2 by 2 times 3.
right. So you're done with the first row. We're going to move on to now.
To the second row.
All right. So what's that going to be?
So then 6 times 1 plus 0 times 3.
Right. I'm gonna call on somebody else to make sure they understand it. By the way, Nicola and Romano, I don't call Ale much because I feel like Ale just go to it. I feel like Ale know the thing already. I doesn't call Ale much, because the amount of work we do together over Christmas, I take it Ale good in this. Don't they know horrors and think I'm forgetting Ale. I just always think about Ale.
Sir, we cool, sir.
Okay, good.
Yeah, we're good.
Let me call Mira. Mira, continue the matrix multiplication for me. So continue. So continue where Christian left off.
Okay. So -1
Mm-hmm.
by 2 plus 2 by 4.
So -1 by 2 and 2 by 4, yeah?
Yeah. Then next line, 6 by 2 plus 0 by 4.
Okay. Okay. I see ya. Nice. Regina, you getting through with this matrix multiplication?
Yes, sir.
All right, Chloe. Chloe, let me know what's going on. Chloe, let me know what's going on.
So I had, being honest, I had a little struggle doing BC.
Yeah, it giving you some trouble to do the matrix multiplication.
Yes, sir.
Okay, I see. Which part specifically?
So I just forgetting how like the structure of the row by column thing again mix up. But I
Okay.
catching on though.
That means we got to do more practice. So I will remember you. Right? You see, like, look how Joshua get it. You could get it the same. I trust. You will get it. Don't worry. So, Mira, where's -1 by 1? Quick movements, Mira. Where's -1 by
1,
1? Nah, -1. A negative,
-1,
where's 2 by 3?
6,
Where's -1 plus 6?
5,
Okay. Where's -1 by 2?
-1 by 2 is 1.
Whoa.
Huh?
Let me take your time. Let me take
Wait,
your
wait,
time.
wait, 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 wait. -2,
-2. Yeah.
right?
Hey, the amount that weight you tell me just now, I could have swear I become over, or I swear I become obese, you know. The amount that weight you tell me. Yeah.
Okay. And then 2 by 4, 8.
Right, where's -2 plus 8? So imagine you
6,
take 2 from 8.
6, 6, 6,
Where's 6 by 1?
6.
Earlier, if this was Jessica would have say 7. Romano and Nikolai. I remember that uni lives. I
So where
asked
is
Oh,
she
yeah.
always, bro?
I asked Jessica, where's 6 by 1? And she says 7. I
So,
don't know what Jessica did, boy. It'd be real fun if Jessica did join the class.
Yeah.
6 by 1 is 6. 0 by 3 is 0. 6 plus 0 is 6. 6 by 2 is 12. 0 by 4
12,
is 0.
0, 12.
So question,
So I
guys.
get the answer for this. I hope you know.
Okay, big up you. Big up you. So I guess the only people having trouble with this is Chloe. Anybody else having significant trouble with this? With the matrix multiplication? Let me know now.
Sir.
Christian, you having significant problems?
No, sir.
So I have a question.
Yeah, Jelani?
So for the ABs now equals to BA, you could just write a statement saying because the multiplication non-commutative, or you had to do all the calculation.
Yeah, do all the calculation.
We,
Yeah.
okay.
Because how you know it's not commutative? You gotta show them. You gotta show them proof. You know? So yeah.
Alright.
So now you could, Jelani, now you could come and say, because you prove it, right? You show what BA and AB is. So you could say, since AB is not equal to BA, matrix multiplication is what?
Non-commutative.
Right. Okay, great. You wanted me to look at the different transformations?
Yeah, so the different degrees.
Okay.
Thanks.
So we look at 90 degrees anti-clockwise already, which is the same thing as 270 degrees clockwise. Which one you want to look at next?
So we could go down and look at the 180.
180 degrees clockwise and 180 degrees anti-clockwise is the same thing. So there we go.
Okay.
So Chloe, I'm gonna call upon you, right? So Chloe,
Yes,
it's the exact same procedure. We are taking So I'm going to label this 1. I'm going to label this 1 as well. I'm going to label this -1. I'm going to label this -1. So Chloe, we want to see how this transformation affects the x point and the y point. That's what we want to see. So let me just say that is 180 degrees clockwise, right? 180 degrees clockwise. So let's start off over here, Chloe. Chloe, if I start off over there, what is our point? What is our point?
So 1, 0.
1, 0, right? If I rotate 180 degrees clockwise, wouldn't I end up over here?
Yes, sir.
Great. And what point would that be?
-1, 0.
Right. So if that is the case, Chloe, then my x value changed from 1, 0 to,
-1, 0.
all right, cool. So I'm going to put that in my matrix over there. Because remember, this tells you what happens to the x value. All right. Let's go on the y-axis now. So Chloe, imagine it was over here, right? What is our point?
So 0, 1.
That'll be, yeah, excellent. You learn. You learn from your mistake. And if it's 180 degrees clockwise, where would I end up at?
So by the -1.
Exactly. I'd end up at the -1. So what would I now become?
-1, 0.
Nah. If you're on the
0,
y-axis,
-1.
right. So what would I write over here?
So 0, -1.
Right. Let me just see. Yep. Watch. Are you seeing that? Are you seeing that badness? Are you seeing how the badnesses go? You don't have to remember anything, though. You don't remember anything. Once you know this, it's pretty powerful. You seeing that, right? Jelani, you seeing that?
Yes, sir.
What we get? What did we get?
-1, 0, 0, -1.
Right. Okay, Romano, I want to help him with 1, right? But all you understand how the hack does work, right? All you're doing, you're gonna go on the x-axis. You're gonna start off on the x-axis. You're gonna apply the transformation, and you're gonna see where you end up. Wherever you end up, you're gonna place that over here as the first column. Then you're gonna go to the y-axis, apply the transformation. Wherever you end up, you're gonna put it in this column. That's it. And you don't have to remember a single thing. How fun. Jelani, how you feeling about this, boy?
Feeling real good.
Yeah, boy. If you go in school and show people this, it could be like, boom, booklets. What? This is some extraordinary stuff.
Really.
All right. So Romano, um, let me look at 270 degrees. Let's look at 270 degrees anti-clockwise.
All right.
Now, Romano, 270 degrees anti-clockwise is just what in disguise?
Is this what?
It's what in disguise. What is it in disguise? It's actually just what? Is the same thing as what?
90, sir.
Is same thing as what? 90 what? Tell me, Romano. Come on, Romano. Okay, I'll give you some help, right? Give you some help. So, Romano, I'm gonna start here, and I want you to tell me when to stop, right? Tell me when to stop. So we're gonna rotate 270 degrees anti-clockwise. Anti-clockwise is in this direction, right? Yeah, agree?
Right, yeah.
So how much degrees is that?
90,
How much is this?
180,
How much is this?
270.
Right, so I end up over here, right?
Yeah.
Okay, now watch this. Whoop. So that is what? What's that?
Then 90 degrees clockwise.
Right. Yes. Yes. The whole point of this, Romano, we see some circle, we see some angles in a circle.
360 degrees.
Right. So 270 degrees anti-clockwise is just 90 degrees clockwise. Who would have thunk it? Right? 180 degrees clockwise is the same thing as 180 degrees anti-clockwise. 90 degrees anti-clockwise is just 270 degrees clockwise. You know? Great. So Romano, you want to work with 270 degrees or you want to work with 90 degrees?
We look at 90.
I prefer that as well. Honestly, prefer that. So like, Jelani, and we know you're gonna work, right? We know you're gonna work. Come on, man. We know you're gonna work.
Yes, sir.
Yeah, we know you're gonna work. Would you rather work with 270 or 90?
90.
I agree. So we're gonna call this one. Call this one.
I too much out to them for the object.
Yeah, that's too much turning. So I'm gonna just keep this thing consistent. It's -1. Right. So Romano, where am I gonna start off at? Where am I gonna start off at?
1, 0.
1, 0, right? Because we want to see what would happen to the x value after the transformation. Make sense?
Yeah.
Enter point is made up of a x and a y value. A point, x comma y. A point.
Huh?
A point isn't a point made up of a x and a y value.
Yeah.
So Romano, think about it. You know, it makes sense what we're doing. Because aren't we trying to see what happened into the x value first and what we doing after?
We go in 90 degrees clockwise.
Wait, in all the previous examples, after I'm done with the x value, what do I move on to next?
The y value.
Exactly, because our point is made up of a x and a y value. And Romano,
All right.
if you're applying a transformation, wouldn't the transformation affect the x value and the y value?
Yeah.
Yeah. So I hope that makes sense. So we want to rotate 90 degrees clockwise. 90 degrees clockwise, wouldn't that just be over here?
Yeah.
All right. Where did I end up at?
Negative. No,
Take your
0,
time.
negative. 0, -1.
Aha. So like, tell me what I'm gonna put in the matrix.
So it will be 1.
No. You put in, okay, so in the transformation matrix, you put in the transformation that happened. So what happened to 1, 0? What happened to the 1, 0? It got transformed to what?
The 0, -1.
Right? Okay, now we're gonna apply the transformation to a
Okay.
point on the y-axis. So if you were over there, right, and you're rotating 90 degrees clockwise, where would you end up?
1, 0.
Yeah. So you started off here at 0, 1, and you ended up at 1, 0. So what am I gonna put over here?
1, 0.
Yeah, let's see if that's correct. Yep. Watch. Watch it. Rotation 90 degrees clockwise. 0, 1, -1, 0. Yeah, Romano, this is pretty powerful stuff. Yeah. So Jelani, you feeling satisfied now that it worked
Yes,
all?
of course, sir.
Nice. If it have
So,
anybody that do fully understand this, someone now you know because I find this is so much more efficient than having to like dedicate so much memory in your brain just for these three things. You could come up with this on the spot.
so I have a question.
Sure.
Did we do scalar transformation matrix?
Yeah, a scalar is just multiplying a matrix by a specific number. So like you see this matrix over here?
Yeah.
If I multiply that by 2, that'd be a scalar multiple. I would just
So
end
it
up with
increased.
-2, 0, -2.
Oh, okay, okay.
Scalar multiplication is just when you scale up the matrix, you multiply it by a number.
So what's the my teacher was doing something with key factor. I was like real confused. Something with that.
Enlargement,
Yes, like yeah.
you're talking about other type of transformation. I think you're
Oh, I
talking
thought I
about
was.
I think you're talking about like the questions where you have like an enlargement like that, and you
Yeah,
find
did
the
we?
center of enlargement with the scale factor key.
Yeah, did we do that?
No, we didn't do that. That is a different topic.
Okay,
That's not matrices.
I
All
guess
right.
so.
I got another roll call here. Mira, talk to me. On a scale of 1 to 10, how lost are you? Like, you understand this little trick over here or no? I'm not sure if I had your attention. Okay, I'm not hearing Mira. Nikolai, you understand the trick fully?
Yes, sir. Make sure you memorize this, sir.
Right, so Nikolai, in the trick, you're just trying to see what happens to the x point after a transformation, and then the y point after a transformation. Understand?
Yes, sir.
So like, okay, if you started off at 1 comma 0, after it undergoes a transformation, it will end up over here. So you put it over here. Then we're gonna look at the y value. If you start off over here, you go end up over here. So you put that down. That's so simple. It's so simple. You're sure you
Yes,
understand
sir.
it, Nikolai? If you need me to go it over again, I will.
Yes, sir. You remember I was working with this with you, sir.
Okay,
So
okay.
I don't understand.
All right. Christian, talk to me. You lost?
No, sir, I understand.
You sure? Because I
Yes,
did
sir,
ask you
sure.
before. All right. Chloe, let me know what's going on. If you're confused now, is it time to tell me?
Nah, sir, I good with you.
You sure?
Yes, sir. Yes, sir.
Jazara, I saw Jazara unmuted. Jazara, talk to me. Let me know what's going on.
Yes, sir.
Wait, breaking up a little bit. Struggling to hear.
Sir, I feel understand.
Okay, nice. Joshua, did this method confuse you, like, to come up with the transformations? Did it confuse you, like, really, really bad?
No.
No? Okay, happy to hear that. Um, Akira, I'm not
Yes,
talking
sir.
much to you. Don't dig no horizon thing, eh?
That's nothing.
You good?
Yes, sir.
Ramadan treating you well?
Yeah.
Yeah? Okay, nice. You understand the trick?
Yes, sir.
Okay, Ariel, what about you?
Yes, sir, good.
All right, nice. Nia, talk to me, Nia.
Very good.
I want to hear you great.
Yeah, I am great then.
That's good. Mira, put on the dabbler and write and start writing notes in the book. Joking
Oh,
with
sir,
me.
I didn't know what you mean.
You understand the hacks or no?
Yes, I understand it.
Because I doubt all you're gonna remember all of this in the exam. I doubt. I highly doubt that.
Also,
Yeah.
we would.
I had to make a TikTok video about this. I feel that'll go viral. Because I don't think
Yes, sir.
like
Sir, I'm gonna understand it. I'm gonna remember it in XCX, so trust.
because like I spoke to like Chris from Adapt Tuition and some other teachers, popular teachers, and they don't know about this. They don't know about the basis vector and whatnot. Yeah.
Says Albert Einstein.
It's not Albert Einstein. We just stay back to the end of the class and we head and we figure it out in eventually. That's what happened. Yeah. Okay, Regina, let me know if you're ready to move on. Regina, I need a confirmation. Can I hear Regina? Ria, you good?
Yes, sir.
Okay, Ria, how is Ramadan treating you?
Good.
You starving? Because I know this fasting is being intense. I've fasted
Yeah.
myself. It's being intense.
Yeah, it quite intense, but it not so bad.
Okay.
It's just like not eaten.
That yeah.
Which I
Um,
mean, it it kind of hard, but yeah, I used to.
you gonna make it, man. All right. So, guys, by the way, Jelani, is the same procedure for these, you know? Jelani, I swear to God, is the exact same procedure. Like, if you
So
want to come up with the transformations, is the exact same procedure.
for the
All you had,
reduction.
all you had to do, right? So, like was 0, 1, 1, -1, -1. Like, okay, watch this, right? reflection about the x-axis. So like should work out the same, I presume. Let's see. Reflection about the x-axis. Pass that off over here. Okay, it might be a bit different, to be honest. Might be a bit different in the concept. Let me see.
Because I'm seeing 0 and -1. I understand the 1 and 0 point, but the
Now, like this real simple. Like, okay, let me look at an example, right? Imagine we have 1 comma 1 here. That would turn to 1 comma -1, yeah?
yeah,
So the x value, did the x value change?
no,
No, so that's going to remain as 1, 0. And the original x value, we treat it as 1 comma 0.
yes,
Okay. The x value though. What happened to the x value? I mean, what happened to the y value? It went from 1 to
change signs.
right. And we to represent the y value, we say 0 comma 1, right? But it changed
Yes,
signs, so it would now become 0 minus 1. Let's apply that same concept to say a reflection about the y-axis, shall we?
yes,
Like
sir.
if it's a reflection about the y-axis, it would have went from 1 comma 1 to say minus 1 comma 1, yeah?
Yes, sir.
So like if you compare the x values, like forget about, we'll come up with it ourselves. What happened to the x value? It went from 1 to
Change signs, the -1.
right. So that's we typically use 1 comma 0, but since it changed sign, it's gonna be minus 1, 0. Yeah, with me?
Yes, sir.
And the y value, is the y value change?
No, sir.
No, so I'll go right.
0, 1.
Bam. Look at that. Figure it out. Light work.
Yeah.
Yeah,
So you tell me is the first one in
So
equation?
can you do that again, sir? I wasn't really paying attention.
no problem. All right.
It's crazy how you come up on this spot.
You know what they say? One math vibes, never two. That's what they say. Yeah. I'm telling you, like math's real cool. You just have to sit down and think. Math's real cool. Like you'll be blown away by how cool maths could be when you figure things out. You'll be like, I never know I could do this. Trust. All right, so let me show you this process one more time, right? Like quickly, because I want to move on to some past paper questions. So like 1, 1, -1. First things first, guys. What are we using to represent x? Like x by itself.
1 and 0.
1 comma 0. And what are we using to represent y?
0, 1.
0, 1. Chloe, and you yourself told me that x is 1 comma 0 and y is 0, 1. And as you were telling me, Chloe.
Yes, sir.
Right. So let us do. Okay, let me ask Ollie what this could be. This look like a what? If Ollie had to say.
Reflection on the x-axis.
Nikolai, you agree? Reflection on the x-axis.
Yes, sir.
All right, so Nikolai, this point here is what?
1, 1.
Okay, what's this point?
1 minus 1.
So Nikolai, did the x value change?
No, sir.
So that wouldn't change, right? So what do we use to represent the x value? Remind me, what we using to represent the x value?
1, 0.
So I'm gonna write 1, 0. What about the y value? Did the y value change?
Yes, sir.
Right. So instead of writing 0, 1 for the y, what would I write?
Minus 1.
That is it, you know. Watch 1, 0, 0 minus 1. Reflection about the x-axis. That bad, Nikolai?
Yes, sir.
Okay.
I've got to remember and everything too, sir. And quick too.
Yeah. Real badness. Let me try another one, right? So, Christian, I want you to tell me what does it look like? What does it look like, Christian? Look at the purple dots. What I look like? I'm not sure if you see any purple dots, but what I look like? It look like a what?
Right angle.
Nah. Imagine it is a mirror, right? It looked like the purple dot was reflected about the what?
Oh, the other purple dot right there.
Yeah, it looked like a reflection about what axis?
What the x-axis?
Nah. Watch. This is the mirror, you know. This is the mirror.
The y-axis?
Yeah, yeah. Because if you have a mirror over here, it wouldn't reflect any mirror.
Oh, oh yeah.
Yeah, imagine you have a mirror, you holding up a mirror here. Wouldn't you see it in the mirror?
That's it.
Yeah. So what is point will be?
That would be 0, 1.
Nah. Nah. When you tell them a point, you have to tell them the x value first, then the y value.
Oh, okay. Well, the x value is 1, 0.
Nah. Wait up. Read off the x value from there. So read off the value along the x-axis.
Oh, negative 1, 0.
Nah. So -1. And where's your reading along the y-axis now?
Negative 1, 1.
Right. Let us apply this now to what we want to figure out. So I want you to compare for me the x values. It went from 1 to what?
1 to negative 1.
Right. So how do we represent x again? X is represented by what?
1, 0.
Right. So if we change any sign instead of 1, that would turn to what?
Negative 1.
It's a -1, 0. Why? Because we change the sign now. So that'll become -1, 0. And compare the y values now. The y values. Did it change?
Yes, it changed.
You sure?
1, 1. Yeah, it was negative 1. That was 1, 1.
Okay. So the x value changed. Watch. So for a point is made up of an x and a y value, right? So the x value here was 1, and the x value here is -1. So the x values changed. But did the y values change?
Oh, no, sir.
No. So since the y value didn't change, I'll just write back 0, 1, because that never changed. And that's how I figure out the transformation.
Oh, okay, sir. I understand now.
Okay, nice. Jelani, you're smiling like you don't have to remember this at all. You don't have to remember this at all.
Yeah, I'm smiling right now. I'm
Yeah.
glad.
Nicola, you don't have to remember this at all, boy. For anybody
Yes,
that
sir.
for anybody that does understand this hack, kudos to you. You've just saved yourself so much mental stress. Yeah. If you have anybody in class that would like me to run through back the hacks, now is your time. Now is your time. Vinaya, Regina, Ariel, Akira, Joshua, Jazara, Samir, Karina, Romano, Mira, Nikolai, Jalani, Chloe, Christian, Rajiv Dwarika. I see.
Being honest, I understand the first step, but this last step that you do, I don't understand.
So, Miss
What's going on there, boy?
Sir,
over the back.
excuse sir.
Yeah, Nikolai.
Me and Romano has come up with a statement during your teaching for the x and y axis now.
What's that? Tell
Is
me.
Romano thing that?
Tell
You
me.
see how on top there it have x and in brackets 1 comma 0. We have 1x and 0 reason why.
Wow. Wow. Wow.
Sir, I got send you what we talk about, sir.
That's good. Send me. Oh, they want me to blow all their mind quickly? Like blow all their mind, like out of this world?
Yes, sir.
I want you to tell me where's the identity matrix. Where's the identity matrix fast? Tell me.
So, 1, 0. 0.
Right. Remember this, what does this really represent? This really represents a transformation for the x value, and this really represents a transformation for the y value. Now we know that the identity matrix does nothing, right? Like it gives us back the same thing. Nikolai, isn't that what the identity matrix does? It gives us back the same thing if you multiply.
Yes, sir.
Okay, now watch this part. Watch this part. We said that x was 1, 0, right? So 1, 0. And where's y?
0, 1.
Right. So if you write back x as 1, 0, and you write back y as 0, 1, it means you're changing nothing. So this is how you could prove the identity matrix too. That's the identity matrix.
So it came from the coordinate of X
Yeah.
and Y.
Yeah. Yeah. Because if you look over here, anytime I had a sign change, you would write like minus 1, 0. But if it's not changing at all, wouldn't you just write 1, 0, 0, 1? Think about it. Some deep stuff. Some deep stuff. I get that this isn't for everybody. But for
So
those of you,
basically the Cartesian play prove everything.
yeah, yeah. Because truth, okay, when you do electrical engineering, or like if you do engineering maths, you learn about span, basis vectors, you learn about all these things, and it makes so much more sense.
Right.
Because all the transformation matrix does, it applies a transformation to the x, and this part over here applies a transformation to the y. That's really what it does. I'm not sure if
Oh,
you
I now see the pattern.
because
Yeah.
watch
Makes sense.
watch it again. This is for the x, right? This part
Yeah.
of the matrix tells us what happens to the x value.
Yeah.
So if it's minus 1, 0, watch. The reason why we say minus 1, 0 is because if you look at it, the x value changed sign. And the x is originally 1, 0. So if it changes sign, it'll be negative 1, 0. And then we look at the y value. The y value didn't change, so I just write back 0, 1. So if both of them don't change, wouldn't I just write 1, 0, 0, 1, which is the identity matrix?
Yes.
Yeah, that is it.
Nah, so you're bad.
Thank you, thank you. Thank you. All right. Chloe. Chloe, you there?
Yes, sir.
All right, Chloe, let me explain what happened in here, right? You understood this?
Yes, sir.
Okay, good, good. This one kind of confusing, yeah?
Yes, sir.
All right. Let me run it back one more time.
Yes.
After I do this, I want to go through one rare thing that does come, and then we'll just do a bunch of past papers. I'll get all the coffee and thing now. We grinding matrices tonight. Like tonight we just finishing this. We never looking back at this again. So like grab all the coffee and thing, man. Yeah. Level
You
vibes
would?
tonight.
Coffee just make me sleepy.
Nah, boy. Can't be drinking coffee.
Yes, sir. I don't even like coffee, sir.
Ask Nikolai. Every time
Evil.
I've ever done a 24-hour live, I rarely drink coffee. I just saying that for the plot. Everybody just say coffee, but I don't drink coffee.
Yeah, it's true. But I know Jelani would go with the monster. But then
Yeah, the
again,
Monster and the Red Bull.
No, no,
yeah,
no.
he
Monster.
went
Yes.
extreme.
I
Red
got the
Bull
extra
nasty,
energy.
monster all the way, buddy.
But a Monster and a Red Bull? You're crazy. You want to kill yourself, man.
He
That's
went
Nah, that's just
extreme.
the extra energy, so we mean
that's crazy, boy.
Crazy is all
coffee
nasty.
have a limit
That
though.
is more than just extra energy right now.
Yeah. All right. So, Chloe, I want you to understand that a x value in simplest form could be represented as 1, 0. And you saw that for yourself, right? Like a x value is just 1, 0.
Yes,
Yeah.
sir.
And where's the y? Where's the y value?
0, 1.
Excellent. 0, 1. Let's just say you are reflecting about the x-axis. Where's our point? What's this point?
You can ask for that.
What's our point over there? The screen point. Chloe, what's our green point over there?
I don't know.
Now you know. A point is made up of
Oh,
an x and a y value.
so 0, 1.
No. So a point is made up of an x value and a y value. So x comma y. What is the x value?
1.
Right? So the x value is 1, right? And what's the y value?
1.
What's the point?
1, 1.
Right? 1, 1. If you reflect that about the x-axis, where would you end up at? What point?
If I reflect it about the x-axis.
Right. So imagine you take a mirror and you put it over here. Wouldn't it be reflected here?
Yes, sir.
So what was this new point called?
So it will be 1. No, it will be 1, -1.
Right. Let's compare the x and the y values. Did the x values change?
Yes, sir.
You sure?
No, the x value didn't change. It remained the same.
Okay, if it remained the same, then it would remain as what? What we say x was?
So x is 1.
X is 1, 0. So
1,
if it
0.
doesn't change, I'll just write back 1, 0. However, did y change?
Yes, sir.
It changed from 1 to?
-1.
Right. So y would change from 0, 1 to 0 what?
-1.
Right, and that's it. That's it. That's the whole thing.
Oh, okay, sir.
Yeah. Great. We have no memorization to do. That's great. It's great news. You know, this is the first time I never show any of my previous students this. Like, we literally come up with this, Nikolai and Jelani. Yeah, we literally come up with this. All right. So let me show you guys some other stuff you need to know. How are you all with simultaneous equations? Talk to me, guys. How are you all with simultaneous equations?
Good enough, sir.
Good enough? What we go see?
So I just saying that for me alone, you know. I don't know about the rest of them, you know.
Oh, they're gonna hate me. That's all I will say. Oh, they're gonna hate me.
Nah, sir, I don't think simultaneous equations go have anybody hating, sir.
Yeah, sure.
Yeah, everybody here to learn, sir. Who gonna hate?
That's some motivational words. But you go see what I mean when you do the question.
So go and give us a real hard question.
Wouldn't say hard, it's just real annoying.
Nah, some thinking question.
All right. Somebody read this one. Somebody, anybody.
Finding the transformation matrix when given the object and image. In these types of questions, they will give you the object and the image, but you have to figure out what the transformation matrix is. Portion. Simultaneous equations approaching thread lightly.
Yeah.
Example. A transformation U maps the parallelogram OABC with vertices 0, well, no, O, which is 0, 0, A, 1, 2, B, 5, 1, and C, 4, minus 1, until O prime, which is 0, 0, A prime, which is 2, minus 1, B prime, which is 1, minus 5, and C prime, which is minus 1, minus 4. Determine the matrix U which maps the object onto its image.
What if I told you guys you could do this question instantly based on the hack I just showed you all? Or what would you say?
Yeah, but then you have to find out if it's at 90 degrees or something like that.
No,
Is
no,
our
no.
rotation?
Olha, the hack I showed you just now will work for this, right?
Yep.
Like, let me show you the traditional working for this. The traditional working for this type of question. This is the traditional working. All of that. This,
Never.
this. Let me show you how it would look like with the hack, right? Let me show you. This is insane. So I want to let you pick a point for me. Pick a point. A, B, pick a point. Pick a point for me.
B.
B, all right. B is 5, comma 1, right? And where is B prime?
1 minus 5.
Okay, so Nikolai, to figure this out, right? I'm gonna ask that question. Remind me, x is what? How could you write x? X
0,
is
1. Oh,
1,
1,
comma 0.
1, 0.
And y is what?
The 0,
0, 1. If you're comparing this to this, you notice that you notice that the x and y values are what?
they change.
They swap, right?
Yeah.
So this was the x value here. This was the x value here, right? And it is now the negative y value here. You see that, right?
Yes, sir.
This is the y value over here, and it's the same y value over here. You see that, right?
Yes, sir.
Look how simple this is. Since in the transformation, the y value comes first, what do you think I should write here?
Well, 0, 1.
0, 1. And what comes after?
The x.
Let me just supposed to put x here. Wait a Right, the x comes over there. Right, the x comes over there, but what happened to the signs?
It change in signs.
So instead of writing 1, 0 back right,
1 minus 1, 0.
let me check if that's the answer, right? Okay, something looking a bit wrong. Wonder why though. I'm gonna look at it. 1 second. 0, 1 minus 1, 0. One moment. So the y value today is 1 comma minus 5, right? So the y value would come first, right? And then the x value. That's weird. The trick's supposed to work. Not sure why it's not working.
Wait, probably is because you use the positive before the negative, and so. So like where it's supposed to be y equals, well, y 0, 1, and it have the 1 minus 5 is b prime. Is that it? Is we switch it wrong or something else?
Because the correct answer is really 0, 1 minus 1, 0. 0, 1 minus 1, 0. Now I see that the 0 minus 1 coming here, because they look like the transpose. And the 1, 0 coming over here. Okay. Now if it's 0, negative 1, then that would mean, okay, okay, I think I figure it out. All right. All right, so Nikolai, check this out, right? I'll show you the formal method just now. But like, I've seen here that they swap x and y. So like, they swap x and y. Okay, that's what they do. Okay, never mind. I gotta think about it after class. But I know the trick's supposed to work for this. That's weird. Unless I do something wrong here, which we'll see now. So let me show you the formal way to do this, right? So you're seeing that you have an object and you have an image. Or you're seeing the object and you're seeing the image. And according to this here, this represents a transformation of what?
Rotation
Rotation.
270.
Rotation 270. Now a rotation at 270. That's 270. What direction? What direction is this?
Anti-clockwise. Anti-clockwise.
Right.
So you could be 90 clockwise.
Yeah. So it's right. Yeah. Interesting. But let me continue. So let me show you the formal way to do this. So let me call upon somebody I didn't hear in a while. Akira, you there?
Yes, sir.
Right. So Akira, we want to figure out the transformation that maps the original shape, the object, to the image. Now tell me, Akira, do we know what the transformation is at this point in time?
Yeah.
No, I don't know what it is.
No.
That's what they want me to find. If you notice, it said determine the matrix U, which maps the object onto its image. So I don't know what U is, right? I don't know what U is. If I don't know what U is, I'll need to assign random letters. So These transformation matrices are 2 by 2 matrices. So like, I'm gonna say A, B, I'm gonna say A, B, C, D. So like Akira, all these transformations are going to be 2 by 2 matrices. Do I know the elements inside?
No.
I don't know the elements inside. Now remind me, what was the magical equation I told you guys you had to remember? What was the magical equation? How do you get from the object to the image? Remind me. How do you go from the object to the image?
Negative 1, 0, 0, negative 1.
No.
No.
Remind me, guys. What was the magical equation you'd use to go from the object to the image? There was an equation I would have told you all to remember.
So you can repeat that one more time. Sorry.
I gave you all an equation to remember, and you'd use the equation to apply the transformation to the object to give you the image. I just told you all the answer.
That's the T multiplied by the O equals I.
Right. So Akira, let me show you what I'm talking about. This. So the transformation matrix by the object is equal to the image. This is what I was talking about.
Oh.
Right? Right? So we have the transformation matrix multiplied by the what? Tell me, Akira, multiply by the Akira, it was the transformation matrix by the is equal to the what? Can I hear an Akira? Mira, you there? Akira, Mira. Mira, let me know if you hear me. Can I hear an Mira? Ariel, you there?
So,
Okay, look, I see Akira on mute. Yeah, Akira. Is the
so,
transformation matrix by the
no, I'm being honest with you. Just now when you show me, I remember it, and then I don't know how I forget it now. Oh my god.
That's okay, Akira. Let's try to reason it through. The transformation matrix does what to the object? All right, so Akira, the transformation matrix is what does the transformation, right? Depending on what the transformation matrix is, it could reflect, it could rotate, it could do anything. So the
Right.
transformation matrix is going to transform the what? What was the original shape here? What do you call the original thing? The object or the image?
Object.
Right. So the transformation matrix is going to transform the object to give you the what?
Image.
Right. Now, the transformation matrix, we don't know what it is, so we assumed some letters. So we're saying it's A, B, C, D. And we're going to multiply that by the object. I want you guys to look at the object and tell me the vertices. Look at the object, any question, and tell me the vertices for the object.
0, 1, 2, 5, 1, 4 minus 1.
This is why you're going to hate me. You probably imagine this is a lot of matrix multiplication. All right, what is it for the image? Let Akira redeem herself. Akira, what is it for the image?
So 0, 0,
Mm-hmm.
2, negative 1,
Right.
1, negative 5, negative 1, negative 4.
All right. So here what we're gonna do, right, guys? We need to cry. That's what we need to do. Because the amount of multiplication you're gonna do here, you're gonna make you lose here.
So I thought you was going to say something motivating, and I said,
I had to be real with all you when the time calls. Or you're not gonna enjoy this. All right. So Akira, you'll help me
Okay, sir.
So Akira, what is the first row over here?
0. Well, A
Right?
by 0, and then B by 0, and then C by 0, and D by 0.
Okay, great. So you handle that skillfully. Nice. Okay, somebody
A.
else. Help me with the other one.
Joshua.
Joshua, come on, Joshua. Tell me. Help me with the other one.
Um, all right, so which one is it,
Right, so Akira just multiplied these
A by
rows.
5,
Nah. So now we're moving on to 1, 2, because we already did 0, 0.
A by 1, plus B, wait, was it supposed to be, oh wait, yeah, B by 2,
Nice.
C by 1, D by 2.
All I had to big up the man, Joshua. He come back. Big up Joshua, boy. Right? Are you not hyping up the man enough? Wait, boy. Some classmates you have here, boy. Nah, boy.
Nah, congrats. Congrats.
Right? Romano, get off that bed. Hey, Nikolai added, I watch back the record and I see when this man go in the bed and pull the blanket.
Yes, sir.
Wait, boy. I never see more.
So we have proof to blackmail him, you know, sir. As if he parents didn't see it already, you know.
Yeah, boy. For his wedding, we had to show everybody that, boy. Rom- Romano, when you invite me for your wedding, I will talk to the people that show anything and somehow I go get them to show that. Lucky he was in the bed the whole time. See that? Best we just now boy Romano boy disappointed was as my son. I think Nikolai is my son, and I think Nikolai is my son.
Wait, sir, die why to one leave him, sir.
Wait, boy. But you see, Tavon is the same thing. Tavon overlove his bed. Tavon is sleep too much. I just get vexed with him. The amount of time Tavon is sleep.
So what happened then?
I don't know, boy. Maybe like the child get mixed up. Like, like in the room, I was gonna collect my child and they swap you with Romano. And I end up picking up Romano, boy. Yes. I feel like what happened, Because Nikolai really could be my son, and you could be Tavon's son. The mannerisms there. Because like Nikolai hardworking like me, stay up 24 hours grinding the maths. You go do the work, but then you go in the bed for a little hour, 2 hour, then you come back. Right? So enough with the chat. Chloe, help me with the 5-1. Come, Chloe, redeem yourself. Chloe, with 5 on the 1.
A by 5,
Right.
B by 1,
Mm-hmm.
C by 5,
Right.
D by 1.
I'm proud of you, Chloe. Should see the smile on my face, boy. I really am proud of you. You feeling good?
Yes, sir.
Nice, man. Nice. Help me with the 4 - 1 while you're at it. Smile even more. Come, help me with the last one.
A by 4,
Mm-hmm.
um, B by -1, C by 4, and D by -1.
And that whole thing gonna be equal to what? It's just over here. All right, Jelani, you there?
Yes, sir.
All right, Christian, you still with us? Christian, you still alive after all of this?
Yes, sir.
Okay, Christian, I'm asking that question, right? You're gonna help me simplify. That's your job.
Wait,
So, nice, fine, it's easy, it's easy. I would tell you all if it's something hard, right? Where's A by 0?
0,
Right, where's B by 0?
0,
Okay, where's C by 0?
0,
Where's D by 0?
0,
Where's A by 1?
1.
Think
No,
think back.
A1.
Think
1A.
Yes, think back in the form 4 class, right? Remember, if you see x squared, and x squared was really 1x squared, but the one it wasn't showing you that it was there, but it was really 1x squared. So a by 1 is actually just a. Think about it. How much a is you see in here?
Yeah.
How much a is
True.
this? See in 1a,
1A.
right? Where's b by 2?
B squared
Nah. B squared is b by b. Imagine you
or
had
2B?
imagine you had one broom and you double. How much brooms you have now?
2 brooms.
Right. So 2b. B by 2
Okay.
means where's c by 1?
C.
Right? What is d by 2?
D. 2D.
2d, right? Imagine you had two ducks. Imagine you had one duck and you have a special location that said curry more than one. And you got to double the amount of ducks you need.
Why I want to carry the doctor?
So you had to double the amount of ducks you have. Hmm.
Yeah.
I know with curry duck, eh? Yeah.
Yeah, me neither, sir. I don't like how doctors taste.
See, man. But I don't know why everybody like duck though. I find ducks real cute.
So
Yeah,
you could
Kira?
eat ramen and red bean and not like
Bro,
something wrong with you.
Exactly.
all you, allow mo na. Oh God. Hey. Where's A by 5? Wait, Akira, when I go Musk, when I go Musk, like
Yeah,
the day I eat,
yeah,
after we say prayers, we'd go and they would give the gifts to the children, they have
right.
food and thing.
Yeah.
That's the only time you'll catch me eating. That's the only time you'll catch me eating. Duck.
So I think you just need to get a good curry duck. You're
No,
probably right.
my mother is a boss. She's really make good food and I just nah.
There's something wrong with you.
I'm a very strange guy. A very strange guy. Think about it. I willingly do 24 hours on maths. I don't like curry duck. I hate ketchup.
For real, and you just eat red bean and ramen.
So,
Yeah,
sir,
boy. Yeah, boy. Real
so, sir,
strange. Yeah?
if somebody offer you food, we have beef and everything, you go take it?
Nah, I tell you, I can't eat beef. Like, I just can't eat it. I feel like I eating a dog. I can't eat a dog. You can't eat a.
What?
I.
Sir, that's
Sir,
how it tastes. It say it tastes dog like beef.
what?
No. I'm saying, like,
Dog?
no. Hear what I'm saying, eh?
Bruh.
You know how dogs have feelings and they're like smart animals?
So what
Yeah.
about the chicken you just be eating and take have feelings too?
Chickens don't have that much feelings. I see chickens
Yeah,
eat
Are
other
you
chicken's kind
vegan?
of dumb, not gonna lie.
chickens as eat other chickens, bro. I've seen crazy stuff. But like
Yeah.
cows sensitive. Cows have feelings. They're like big dogs. They're like big puppies. I could never eat a cow. Yeah.
So you're basically saying that you know what dog tastes like and
No,
beef that
no,
does taste
no,
like that.
So it's
no.
not like the vegan people.
That
So
I
I
see.
I
Delani,
The
that's why I
vegan.
see him. Because
I
the
Vegan.
man say
just
the beef tastes like dog.
You
no
don't eat your red bean, not your
I
protein, but you turn
oh
vegan.
God. I saying that I could empathize with a cow. The same way you could empathize with a dog. You know, because like
So you do eat goat either.
I don't eat goats. I eat lamb though. I eat lamb. I like lamb.
So
Whoa, wait,
what
wait,
about the
wait,
lamb
wait, wait.
feelings? And the
So,
lamb
so
have
you
feelings
just
too?
eat lamb. One of the cutest animals to ever
Yeah.
exist.
A duck
Lamb,
have
No,
feelings
no.
too.
The
but
cutest
you're
animal
just
to ever exist is a squid, no lamb.
A
Lamb just
squid.
tastes good.
A squid.
Squid?
a
What?
squid now. You lost. I feel like you lost the whole
I
I
class
like
there.
a
What?
squids,
squid.
okay? I
Ooh.
like
Yeah.
squids.
Man, say
Why
a
we
squid.
venturing to seafood now?
Squid
You
what?
lost the whole class
I
there
like
We
now.
talking about
squids.
farmer, he gone aqua.
He got
Wait, boy. Squid, seriously?
I want to say aqua. Oh my.
Nah, boy.
So, but the lamb have feelings just
the
like
lamb
the cow.
exactly just like
Yeah.
the cow. But you can eat lamb, but you wouldn't eat the cow.
Yeah, I don't understand that.
Lamb
The
does taste
maths
better
not
than
matching,
lamb does
sir.
taste
Hear
better
this,
than
hear
steak.
this. Hear this. I think it had to do like with religion. Like I feel like it because I grew up in a strong Hindu environment. Like
Oh, well, that makes
go
sense.
to
Yeah,
temple.
well, you should have
Right.
told
Well,
us
you
that.
should have started with us,
Yeah.
sir.
I talked about that at the start of class. Or was it the form?
Having us debate and things.
But yeah, religious reasons. But I'm not very religious myself.
At least sir don't find us quite cute. That is all. No shade.
Yo,
Yeah,
Why catching strays?
wait. I'm gonna literally Google cute squid and see what pop up. I'm curious. What
No,
happened?
like I genuinely like how squids does look. I've always liked squids since I was small.
No, they actually kind of cute, bro. Watch.
Not cuter than a lamb.
Yeah, but lamb does taste good. Squid doesn't.
Squid just tastes good, man. No, squid just tastes good.
If you like squid since
That
you're young,
I
how
can
you know
agree with.
squid doesn't taste good?
Cause
Squid do be
I
tasting like
taste,
rubber,
cause
but
I taste squid before and I didn't like it, and I say they're too cute to be eaten and not even be tasting good.
Wait, watch this. Like, I can't tell, man, it's not cute. I mean, I think they're cuter things than squids, but like that kind of cute. Not gonna lie.
What is that, sir?
that don't even look like a squid. That look like a AI generated
That is
photo of a
only look
squid.
good in calamari form.
That
I don't know
look like
about
a
that.
frog.
Calamari is so nasty. Ew.
That is tastes so good. Nothing wrong with
Calamari
it.
does taste
Calamari is
good.
Nah,
amazing.
calamari is disgusting. Sorry.
Calamari do not taste good.
Try calamari. It does eat real good.
I don't
Calamari
care
does
how
taste good.
cute it is. Once it tastes good, I eat it. Sorry to say.
Of course you would. Of course you
Well,
would.
lamb does taste good, so now why does eat it?
Like, look at this, genuinely cute.
Okay, yeah, sure, but the lamb's still cuter.
Yeah, but it still tastes good, so I'm still eating it.
Lamb is real good, boy.
Oh, we
Lamb,
know
wow.
somebody can turn vegan.
Wow. I mean, now I'm feeling kind of bad about eating the lamb, boy, but it tastes real good.
Look at that.
So you can't feel bad,
It,
sir.
you're
So lamb
eating,
does taste so
Sir,
eating
I don't
juicy.
it,
really
but
mind
it's
to
not
know.
alive.
Sir, I don't really mind to know. If it's duck, goat,
Oh, look how cute.
anything, I could just
Look
eat
Bad
it.
how
for you.
adorable that is.
That nothing that's food.
It does look like the Minecraft lamb. I just eat lamb in Minecraft and in real life.
Wait.
Same, bro, same.
Well, you think a squid cute, so honestly, I'm not even surprised. I'm not even surprised.
So we have to bring like food for squids in Minecraft now. You will eat it.
Nah, I good.
I genuinely don't get the
That
squid,
game
though.
though.
I mean, like, I genuinely don't get the hype about the squid. I mean, squid's kind of cute, yeah. I feel like octopuses, though. I feel like octopuses cuter because they're actually extremely intelligent. Like octopuses, like
Yeah, but I don't find any seafood that tastes good other than shrimp and sushi and salmon. That's the only seafood that I eat.
Nah, sushi is still real good. Yeah,
And
back up.
well, I never tried lobster, but
I
crab
don't,
and
I don't
nothing
know
tastes
about the
good.
sushi, but the two other things you say, I go do that.
Yeah,
Crab
yeah.
does eat
I'm
real good.
addicted to
Oh, you
sushi.
cannot like crab.
no, but
How are
I
you
tried
even
crab
cook
when I was
crab?
Oh,
smaller
crab,
and
yeah.
it did
No,
crab is
not
like
taste
a
good.
Crab so
core boy.
crab
nasty.
with
Crab
crab
does
with
eat
yeah.
so good.
Crab
Okay,
is
Alaway.
like
back to the
So what?
lesson, please.
Yeah.
Back
Back to
to
it.
maths.
Back to it. You know, we had some random side
We
question
ventured
everybody
into
out with.
food and nutrition.
Yeah, boy, my girlfriend. I'm
Ah,
surprised
so
she didn't
well,
pop
let's
up.
talk about food I feeling to eat right now. Like honestly.
Feeling to eat squid.
Yep, like I get more hungry.
All right, let me continue. So where's A by 5? A by 5. Watch everybody quiet now, right?
5A.
5A. Yes, sir. I was not gonna say
Where's
that, you
B
know.
by 1?
I
Where's B
really
by
would
1?
just not talking about
1B.
squid and octopus and them things, sir.
Where's C by 5?
5C.
Where's D by 1?
E.
Where's A by 4?
E4.
4A. A4
Oh,
isn't wrong, but you would say 4A. Where's B by
I get
negative 1?
mixed up.
Negative 1B.
Negative B.
Negative B. Where's C by 4?
4C.
Where's D by minus 1?
Negative D.
Negative D.
Right. Please don't get lost.
Why is there
Please.
so many calculations?
I told you that I hit me for this one. Right, 0 plus 0 is 0. 0 plus 0 is 0. Cool. Then we have A plus 2B. This is A plus 2B. This is C plus 2D. Right? Could somebody tell me what the red part's gonna be?
5A plus B. 5C plus D.
Right, 5C plus D. Purple part now?
4A minus
4A
B.
minus B.
And
4C
C,
minus D.
4C minus D.
Yep.
And where's the order of that matrix?
2 by 4.
2 by 4.
Because you have,
Two
oh,
rows and
you have to, yeah,
four
you
columns.
have 2 rows and 4 columns. So anytime you have the same order, you are allowed to equate elements. So if anybody is confused, we have 2 rows and we have 4 columns, 2 by 4. Over here, we have 2 rows and 4 columns. So since that is the case, obviously, guys, you think putting 0 is equal to 0 is equal to 0 is going to help us in any way? They're not going to
No.
help us. No. So we could figure
So
about
that's
that. So what I want us to notice something, right? We have 4 unknowns in total. We don't know what A is, we don't know what B is, we don't know what C is, and we don't know what D is. However, I want you to observe that we have 3 equations here. Well, we're going to form it, but 3 for A and B. If you have 2 unknowns, how much equations do you need to solve simultaneously?
2.
You just need 2. Just need 2. Over here, you have 3, but you just need 2. So let's formulate a bunch of equations. So I could say A plus 2B is equal to what? Let me see if I can figure that out.
2.
Right? Mira, what would 5A plus B be equal to? Or you want to start talking about food again, or you go here, Mira?
Yeah.
It's either 5 or 5AB. I don't know. My stomach making a kind of song right now, and I'm studying that.
No, Mira, you had to study the
Yes.
maths. You had to study the maths. We had to study. Right, Mira? So look, this and this is the same order. So what is in place of 5A plus B over here? Tell me, Mira.
1 minus 5.
No, watch. So the 0 and the 0, same place. A plus
Uh-huh.
2B and 2 is the same place.
Mm-hmm.
What do you think 5A plus B is equal to?
5.
5. Nah, 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 nah. I don't want to help on Mira. Now let Mira figure it out for herself. Look, look at what I do. I say A plus 2B was equal to 2.
Uh-huh.
I think you could figure out what 5A plus B is equal to. Look at it and think
What?
about it. 1, yes.
Okay, so but how is equal to 1 and 5? It is
Because both of them have the same order,
uh-huh.
technically speaking, each elements equate to each other. And you just need to figure out what A and B
Oh,
is.
okay.
This is a 2 by 4 and this is a 2 by 4. Both of them is 2 by 4.
Yeah.
You need to figure out what A, B, C, and D is to satisfy this, to give us the 0, 2, 1, minus 1, minus 1, minus 4, 5, minus 4. Right. So then we have 4A minus B is equal to what? Somebody that didn't answer yet. What is 4A minus B equal to? What to call boy? Chloe, what is 4A minus B equal to? 4A minus B. What is that?
Negative 1.
Excellent. Chloe, look how you come for them, boy. Chloe, what is C plus 2D equal to?
So negative 1.
Right? What is 5C plus D equal to?
Negative 5.
Joshua, tell me, what is 4C minus D equal to?
4C minus D.
Yeah, what is that equal to?
Uh, 4C, that's
So look at how we came up with all the other equations and tried to figure out what 4C minus D is equal to.
negative 4, I mean negative 5 minus 4.
Nah. Watch. So the 0 and 0 there, the C plus 2D and the minus 1, 5C plus D and minus 5, 4C minus D is what?
Negative 4.
Yeah. Great. Now, guys, on the top row, you're seeing that we have 3 equations with how much unknowns? How many unknowns?
6 unknowns, sir.
No,
2 unknowns.
2. Christian, you want to say 6, right? But A and B, that's the only unknowns that have there. Just A and B. Yeah.
Oh,
Think about it, Christian. If you know what A and B are, and you could figure out what 2B is, you could figure out what 5A is, you could figure out what 4A is, once you know what A and B is. So you just have 2 unknowns there, not 6. How much
yes.
unknowns it have? Here. Tell me, Christian.
2, sir.
Have
2,
2.
sir.
So here what, right? For me to solve for A and B, I just need to pick 2 out of the 3. 2 out of the 3. So which 2 all they want to pick?
So the 5a plus b equals 1 and the 4a take away b
I
equals
like
negative.
you. I like you. You're smart, thinking smart. Because if you use that, it'll cancel off real easy. Elimination method. So guys, check this out. If you use 5a plus b is equal to 1, and you use 4a minus b is equal to minus 1. What? By the way, show our hands. Well, I can't really see all your hands, but tell me, how much of you guys know how to do the elimination method?
Yes, sir.
Right.
No, sir. I don't know what that.
All right. So, I have a question. If you have one unknown at a time and you could solve for one unknown,
Yes.
like,
Yes,
like
sir.
if you're confused about what we're talking about, let me give you an example. Let me just say you go into a store, right? And you know you spend $20. You buy oranges and you buy apples. You know that the apples cost $10. Can you now figure out the price of the oranges? Let me run that back one more time. Christian, let me just say you go in a store, right? And you spend $20, right? Yeah? You spend $20, you there?
Yes, sir.
You spend $20. Let me just say you buy apples and grapes. Let's just say you forgot the price for the apple, but you remembered that you spent $12 on the grapes. Would you be able to find the cost of the apples?
Yes, sir.
How was the cost of the apples?
$8.
Right. How much unknowns you had here?
All unknown.
Right. If you didn't know what either one was, you think you'd be able to solve it?
No.
Nah. So here what? The problem is we can't work with 2 unknowns at a time. So there's something called the elimination method where you either add or subtract the 2 equations so that one of the unknowns will be eliminated. If you compare these 2 equations, you have 5a over here and you have 4a. If I add that, I'll get 9a. If I minus, I'll get 1a. Doesn't cancel off. Next thing we're going to look at is the b terms. Over here, I have positive b and I have negative b. What could I do with positive b and negative b for it to cancel off?
Add.
Say that again?
So you will add.
I would add. Right, let me ask that question, Christian. Imagine you had 5 and minus 5. Where's 5 and minus 5?
5 and minus 5 is 0.
And everybody could see that in class. Where's 5 minus 5?
0.
I hear it from Jelani. What about the rest of you guys? Romano and Nikolai. Romano, get off the bed. Where's 5 minus 5?
0.
Right. So what do you think b minus b is? B minus b. If 5
0.
minus 5 is 0, what's b minus b?
0.
Exactly. So if I want to cancel off the b term, I'll add both. So what is 5a plus 4a? Tell me, Christian. Christian? Christian, if you had
Yes, sir.
5 apples and you add 4 apples to that, how much apples do you have now?
9 apples, sir.
Right, so 9a. Over here you have
9
positive b and you add in negative b. Where's plus b, negative b?
plus b negative b. No b.
There'll be 0. So you see, The problem was we had two unknowns. What would we just now do?
We solve the unknowns.
We didn't solve it, but we get rid of it for now. And then we have 1 plus minus 1. Where's 1 plus minus 1, guys?
0.
Yeah, 1 plus minus 1 is 0. So we end up with 9a plus 0 is equal to 0. So if 9a is equal to 0, then what would a be?
0.
You don't need to think hard about this, right? Let me ask you that question.
Nah, so
Watch this. Watch this.
-9.
Somebody said -9. Wait, I look at this, right? If we want to get 0, what would I need to multiply 9 by to get 0? What by 9 is 0?
0.
So a is automatically 0. Fully understand that. We're trying to figure out 9 by what is 0. Christian, and 9 by 0 is 0.
Yes, sir.
So if a is 0, 9 by 0 is 0. That checks out. Cool. So a is equal to 0. Nice.
So the longer way will be just to divide 0 by 9.
That's all. You divide both sides by 9. So that the 9 would cancel off to leave you with 1a. And 9 could go into 0 0 times. So a is just equal to 0. So we have a. What do you all want to do next? We are still missing what? What are we
B.
still?
B.
Right. What could you do that information about e?
Substitute A into one of the equations.
Right. Which equation do I want to plug it into?
First one be like blue.
All right. Plug into anyone. It doesn't matter which one you plug it into, eh? Plug it into anyone. But I'll go pick the first one. So a plus 2b is equal to 2. A is 0. So 0 plus 2b is equal to 2. So 2b is going to be equal to 2. And how would I find for b on both sides? On a simple question to ask, right? What by 2 would give me back 2? 2 by what?
1.
So b is 1. And if you wanted to do the long way, you would divide both sides by 2 to find for 1b. So b is just equal to 2 into 2, which is 1. Great. So we just found for a and b. Awesome. Now I'm going to ask you, I want you to apply the same concept and let's try to figure out this now. So I want you to pick 2. So pick 2. My advice is, if the 5a plus b and the 4a minus b worked, maybe you should use something similar for the c and the d. Anybody have any ideas?
I think we should use the 2 and 1.
The 2 over here?
No, sir. The c plus 2d equals -1 and the 4c minus d equals -4.
Okay, we're gonna have some extra work to do to work that out. If you use 5c plus d and 4c minus d, you will cancel off one time. But I want you to understand why, Chloe. Notice you have plus d over here and you have negative d. What is plus d minus d?
0.
Yeah, and you will get rid of d like instantly. But Chloe, if you use c plus 2d is equal to -1 and 4c minus d is equal to -4, think about it. If you add that, none of them going to cancel off. If you minus that, none of them is going to cancel off. You will actually have to do extra work and you'll have to multiply. You'll have to multiply. Okay, Chloe, we want to get rid of. Tell me about something to get rid of. You want to get rid of C or D?
Now, I'm going to go down. D.
D? Okay, right now we have 1D and over here we have +2. You have an option of multiplying this entire thing by 2. If you do that, you're going to end up with 8C minus 2D is equal to -8. Now, when you look at it, you'll see we have +2D and -2D. So, Chloe, what would you have to do with +2D and -2D for it to cancel off? Do you add them or subtract them?
Plus 2D minus 2D. So
Yeah,
how to add it?
yeah. Where's 2D minus 2D? What is 2D minus 2D?
Excuse sir, but when is class ending?
Rob, can we finish with this question? Yeah, so like
So 0.
give me like give me 15 minutes again.
But okay,
Yeah. Yeah, so but Chloe, that's unnecessary because if you look at this one and this one, and it's already set up for like a scenario, because you see in positive D here and negative D.
Yes.
So best to just use that one time. But I like the thinking though. You could really use any two out of the three, but you have to know what you're doing. The safest one is to pick 5C plus D is equal to minus 5. And the 4C minus D is equal to minus 4. So Chloe, you said to add, right? So what is 5C plus 4C?
So 9C.
What is plus D plus minus D?
0.
What is minus 5 plus minus 4?
Minus 9.
Excellent. Christian, in case you're confused about this, right? Imagine if you take $5 and then you take $4 again. First of all, you'd be a real piper if that was the case. Yeah, let's do that. Christian,
No,
yeah.
sir.
Okay, but Christian, you understand what I'm saying? If you take $5 from somebody and then you take $4 again from somebody, you're a piper. But furthermore, you take $9 from them. Make sense?
Yes, sir. Yes, sir.
Yeah. Right, so Chloe, we end up with 9C. 9C is equal to minus 9. So Chloe, before we divide, right, think about it to yourself. What would I need to multiply 9 by to get minus 9? Tell me,
So
Chloe.
-1.
Exactly, so C is negative 1. If you wanted to do the long working though, you'd have had to divide both sides by 9. So the 9 and 9 will cancel off now.
Yes, sir.
So here it is now. We have C. We know what C is. So how am I going to find for how am I gonna find for D? What do you think?
So me?
Yeah, yeah.
So we have to put it into the next. We have to put it into
You could actually put it into anyone, you know. You believe that?
okay, sir.
Did you know that? You could put it into anyone and you get the answer.
Yes, sir.
Nice. So which one you want to put it into?
So we should put it into the 5C plus D.
No problem. So 5C plus D is equal to negative 5. What is C?
So -1.
Uh, I don't know what D is, and that'll be equal to negative 5. What's 5 or minus 1? What's 5 by
So
negative 1?
-5.
Right? And that'll be equal to negative 5. So to find for D, I'll need to take the negative 5, and I'll need to move it across. So that would become D is equal to negative 5 plus 5. What is negative 5 plus 5?
So 0.
Yeah, 0. So let me ask that question. Do we know what A, B, C, and D is?
Yes, sir.
Right. So now I could figure out what my assumed matrix was. So I know that A is what? What would find A to be? I'm gonna
So
highlight it.
A is 0.
Right. A is 0. Somebody. Where's B?
Negative 1.
Nah, B was negative 1.
Oh, sorry, 1.
Where's C?
Negative 1.
And D?
0.
0.
So I have a
Awesome.
question.
Yeah.
So before you did this, I actually figured it out with the confusion we had. It was actually 90 degrees clockwise
All right.
before you did all the looking. I just wanted to tell you.
So you just use the hack I showed you before?
Yeah.
Okay, cool. Cool. Nice, man. But yeah, this is the official way to do this, the formal way.
So how much marks is that?
You like what, 5 marks? I've
Oh,
never seen a question like this crazy before. But if they bring a question like this to this extent, it'd be like a 5 mark question. Because it's
so
this is crazy. Yeah.
looks good.
Right? We would have covered essentially everything you need to know. So let's do a little recap for transformation matrices now. And that'll be it for class today. In transformation matrices, what is the magical equation you're supposed to know?
T multiplied by object equals image.
Akira, I'm looking at you now. Don't forget this. Akira,
Yes.
transformation matrix by the object gives you the image. Now, let's just say I had the image and I wanted to go back to the object. What would I multiply the image by? Does anybody know?
The inverse.
The inverse.
Yes. Akira, if the transformation matrix does one thing, wouldn't the inverse just do the opposite thing, like backwards?
Yes, sir.
So like Akira, if you add the image and you want to go back to your object, and you'd have to like walk backwards.
Yes, sir.
Well, that is what T inverse does. It just is the inverse transformation. So if you want to go from the object to the image, you use T. If you want to go from the image to the object, you use T inverse. No problem. You need to know this. Uh, Obviously, you need to know how to find for T inverse. T inverse is just 1 over the determinant of T by the adjoint of T. You need to know how to find determinant and adjoint. You need to be able to solve simultaneous equations. But specifically for transformation matrices, you need to know how to do this. What else you need to know how to do? Well, you need to remember the different types of transformations. You'll have different types of transformations. Different types of transformations. But I showed you all the hack to remember them. Shouldn't be that bad. Additionally, you need to know. What you need to know, boy? Combined transformations. You need to know combined transformations. Yeah, that's essentially it. And well, the last thing I showed you, which was finding the transformation matrix given the object and image using the assumed matrix method. Yeah, we effectively finished matrices in a whole. Are they okay?
Yes, sir.
How about
Yes,
you?
sir.
Yes.
Okay,
So we'll be going on to next class.
I will drop a poll. But
Yeah. Nice.
just asking based on who here right now. What topic do y'all want to move on to next? I was suggesting bases because it's common in the newer years.
Yes, sir.
I mean, and basis is a short topic. I most believe we could finish that in one session. Basis is real easy. It's just nobody just teach it, including myself. I can't remember the last time I teach basis, but I don't know how.
You should probably go over binary numbers as well. Wasn't the basis with the binary as well?
Yeah. Yeah. And I'll show you all ways to you remember. Okay, so you see our share hacks here to figure out if you to figure out the transformations if you forget. I'll show you hacks to figure out the conversions and if you forget too. Yeah.
Okay.
But yeah, that's essentially for class today. Right? It was a pleasure meeting the new people. And it's always a
I
pleasure
see.
meeting the OGs, the people that was there from day one. Right? So big up all yourself. Paul, have a blessed night. Later, everybody.
Bye,
I
sir.
see.
Nice to
Right,
Enjoy the
sir.
rest of your night.
Nice to
Thanks,
Later.
thanks, thanks.